I would like to invite our panel. We'll be having a panel discussion. Kim Hazelwood, who is Director of Engineering from Meta. Thank you so much, Kim, for being here. If you can join me on stage. Chris, who is the VP of Special Projects from Star Schema. Thank you so much, Chris, for flying in to be with us here today. Julian Simon, who's Chief Evangelist at Hugging Face. Thank you so much. All the way from France, highly caffeinated, but thank you for being here. And Vijay, who is the AI lead for Zoom. Thank you so much, Vijay. So again, it's a panel, but I would love for it to be interactive. So if you have any questions in the audience, feel free to ask at any point of time. There are 2 microphones here. Please feel free to ask the questions. With that, let's get to the basics of it, right? So Chris, I would first start off this question for you is, what is the difference between AI developers and software developers?
I think this is a great question. But 8th centuries BC, the Greek poet Archilochus said that the fox knows many things, the hedgehog knows one big thing. And I think that's kind of true. The good software developer is a hedgehog. He or she or they are a specialist in their genre. A good AI developer must know the platform, the idea, the domain, the ethics, the impact, the equity, the overwhelming range of issues that are comprised both in what we're doing and what we're doing is doing to the world at large. And I think this is going to be a very different kind of person. Not better, not worse, but certainly a different personality.
That's very interesting. Anybody else? Kim, Vijay, Julian, you guys have any views on that?
Yeah, I mean, there is different things people focus on, right? I mean, system performance versus model performance, right? So it's an example, code quality versus data quality, right? So I think like there is some difference, but it's all merging together, right? So looking forward.
Yeah, I agree. It's AI and software engineering are different things, but one of the beliefs at Hugging Face is that those things should merge. And what I mean by that is machine learning and AI has been crazy complicated for too long. And the skills that you need as a developer, as an engineer, to be good at ML is way too large. So I think Hugging Face and the work we're doing with Intel as well shows that makes it a priority to build tools that make it easy for the normal developer, and I always insist on the fact that I mean that in the most positive way. Developers who do not have machine learning skills, the tools that we build enable them to use state-of-the-art models in just a few lines of code. And whether it's just deploying them or training them or accelerating them with Habana or Intel Xeon, is really what we focus on. So maybe in a few years, we won't even see the difference.
So that's very interesting because, Kim, we were having discussion earlier this morning about how AI developers are so different that you don't care about hardware, you care more about productivity, not even as much performance. Would you shed some more light on it for our audience?
Yeah, I mean, the key point there is when you think about the skill set of the typical AI practitioner, right? What they shouldn't have to think about or worry about at all is very low-level hardware details, right? If they need to understand that to do their job, we've already lost, right? And so it's a really interesting crowd because they're very sort of impatient, like, not willing to go and get a PhD in low-level systems in order to do their job. And so it's just like a completely different type of persona. And like one of the other things that they face that the typical software developer doesn't have to face is just sort of that bouncing around of where are we targeting in the layer of abstraction. And we're still kind of ironing that out. But the key is the higher the better. Right?
That's so important. And Julian, this question is for you. There's a lot of focus on AI training today. But training to a large extent is at least a solved problem. We know how it works. But deployment is another problem altogether, because you could deploy it on edge, you could deploy it on cloud, you could deploy it on sensors, it could be. So how do you see the world proliferating where you can democratize AI in a meaningful way where the world is benefiting the...
Yeah, I totally agree. I think transfer learning is quickly making training a thing of the past for 99% of organizations, right? So the bigger challenge is obviously we have those great models. How do we bring them quickly in production? The keyword is quickly, because we want that software agility into machine learning. Nobody wants to wait 6 months to see the results, especially if you have off-the-shelf models. So you should be able to deploy them in some kind of prod environment in minutes or hours. And of course, you need automation, and it's not enough to have that model in production. It needs to be fast. Latency should be compatible with the business use case. And it's a different thing to deploy on a cloud server or on a mobile phone or on any embedded device out there. So, the common thing is you want to move fast and test fast, but the different thing is how do you optimize, how do you get model size and latency down to acceptable levels for your use case. And again, you have to look at the underlying hardware platform to do that. But if you're just a regular Joe like me, you're not going to be a hardware expert. So you need tooling, hopefully automated, that just works, for you under the hood and optimizes. And again, it's the work we're doing with Intel on this, I think is super important. It's not just us, it's, a lot of other companies are working there. But it's a priority for us. Model in a sandbox means nothing. The truth is in production, and that's where you'll see if the model works. So you need to get there quick and with the right quality level.
Right. Thank you so much, Julian. And one question in that context is from edge to cloud deployment when we are talking, how much does software ecosystem actually play a role? Because if I want to deploy on the edge, I want to deploy it on the cloud, I want to be able to move it around. x86 has one of the largest software ecosystems, and then the other one is the CUDA ecosystem. So how do you see it changing the way that AI gets deployed? Vijay, Kim, Julian, Chris, any one of you?
Yeah, but so I think when you look at the edge, right, so there is a lot of diversity in terms of compute availability, storage availability. So it's constrained to a lot more extent. We're getting better at deploying complex models in the edge, right? But we are still not there to deploy a large language model there, right? So, and the compute is still limited, right? So, for things like quantization, distillation, student-teacher training, surrogate models, and other methods are getting more tooling now. But I think still a long way to go, right, in terms of automation and bridging that gap, right? So as a developer, you tend, similar to what embedded guys used to do back in the days, right? Write a lot of code specific to the hardware and then test all varieties of them. The good thing about what Intel is doing and all the other companies are doing, PyTorch abstracts it from the AI developer a lot of this complexity, and under the hood you have low-level libraries which takes care of it. But still, there is a long way to go.
Right.
Of course, edge covers a multitude of sins, so the term edge device is quite expansive. It can go from whatever is in an intelligent traffic lamp or your Nest thermostat at home to medical devices that we sometimes encounter. My practice is in that field, so I can speak to mainly that, where we encounter highly performance limited capabilities, and we need to put the best of the model, so to speak, the part of the model that is most likely to give you the clinically valuable data into the confines of those often quite limited computing capabilities.
Or in Oculus headsets, I guess.
Oculus, yes.
So Kim, one question for you is that there's a recent announcement of releasing jacks for multi-node, right, that NVIDIA just announced too. What does it mean for PyTorch and considering you're becoming part of the Linux Foundation and all of that stuff, how do you see these frameworks actually playing out?
I mean, the PyTorch, actually, if you go back to the origin story of PyTorch, that's where it gets really, really interesting. So within, every company had their own frameworks. Meta actually had two. So we had, Cafe 2, which had full 100% adoption in production. Nevertheless, a set of researchers from FAIR went a little rogue and said, hey, we just want something easy to use. We don't, and Cafe 2 is not cutting it for us. So we're just going to make our own thing. And so they didn't set out to make a framework, they set out to solve an actual concrete problem. But in order to accomplish that problem, easily, they were like, hey, let's build this thing to make our lives easier. And what was really fascinating about that was if you actually ran the numbers, it was not the most performant thing around at all. Nevertheless, it won anyway, and it won because turns out people don't actually care as much as you and I might like to think about performance, and what they care about is usability and just their own time, optimizing their own performance, how much they can accomplish in a set amount of time, because if it requires a lot of thinking, that's overhead that you have to factor in as well. So it was really, really interesting when it even spread out into production. We realized, hey, actually, maybe the same trade-offs apply. It's an overall optimization to have things be easier to use. And I think the similar lesson happened at Google with JAX, where you can somewhat try and force people to use a framework, but at some point, they're going to speak with their feet, and if they find something easier, they're going to run with it.
So performance versus productivity, Vijay, what do you think wins?
Productivity. I know the story which Kim was talking about. We were in the same team. We saw that, right? I mean, productivity will always win.
Yeah. Right. So because it's an interesting, I think, message for the audience here is that productivity for AI does trump performance. It's all in the end, it's all about productivity.
Because it's cutting edge, right? So eventually when you deploy it at scale and when you have to reduce costs because there's a billion users using it, we will focus on the performance of it, right? So, but to begin with, experimenting and figuring out what to do, it's important to have productivity.
Got it. So one question, let's change the topic, right? We all talk about all these large-scale models, megatrons and diffusion models, multi-billion parameter models. What does that do to our ecosystem? We are seeing climate changes and all of that stuff. From a green AI perspective, where is the world headed? From a sustainability, where do you think all this is going to converge? And Kim, you want to?
Yeah, this is one of my favorite soapboxes that I love to get up on and talk about. And for me, I had an eye-opening moment a few years ago when some numbers came out about the environmental footprint of training one large model being equivalent to 5 car lifetimes. And it was shocking to me. It shook my world. I started to think, oh my gosh, what am I doing? And there's some really interesting angles when you think about environmental responsibility. There are ways that AI itself can help us with the environment, right? So there's that angle. But on the other side, we want to make sure that we're innovating responsibly and that we're not just, hey, let me just throw a whole bunch of machines at it and train and shot in the dark and not being smart. And before I kind of thought of it as a cost wasting metric, but then once you start to realize, no, there's an actual real environmental impact. It's not just wasting money, it's potentially at the expense of future generations. When you start to think about it that way, then it really helps to up the importance of things like efficiency and does it really need to be that fancy? How large do we need this language model to be? Are we just translating a couple languages? Why does this have to be so complicated?
I think we have 2 great advantages in this field. One is we have more and more people like Dr. Hazelwood in charge who are thinking this way, which is great. And the other is sitting to my right, which is that we have As Julian said, training is slowly becoming an obsolete concept. That's a great thing because that means that we can cut down on about, training is about 40 to 50% of all the energy expenditure associated with AI. If we can cut down on that, you don't need to build your own bird. You can just download it. That's what these guys are here for, which is, I think, a fantastic development. Absolutely fantastic. And I think the fact that so many really advanced AI models are so openly available, it doesn't just foster the ideas that we as scientists always like, which is, openness and interaction and dialogue, but it also means that we can stand on the shoulders of giants without having to reinvent the wheel all the time. That's two strange analogies in a row, but you'll forgive me.
So in that question, Julian, because Intel AI Xeons are ubiquitous, right? They are everywhere, all said and done. So considering that you are able to shrink the models, make it smaller from both the environment perspective and the sustainability perspective, how do you see them, how do you see Intel or CPUs continuing to play a role in these deployment side of things?
Yeah, everybody gets excited about the humongous models, but unpopular opinion, I'm not. I'm terrified. And no offense to people building the trillion parameter. I'm sure from an engineering perspective, I'm sure it's amazing. But the customers I talk to, honestly, they don't care. They need to do entity extraction in financial documents, and they need to do summarization of doctor notes, and they need to solve real life problems. They need to go fast. They don't have time and resources or skills to go and work on this thing for 12 months. And so working with off-the-shelf models that are pre-trained, optimized, lightweight, fast, and deployable in one line of code is what I believe what they really want at the end of the day. Again, the average user, the average machine learning customer, they're not excited about the trillion model parameters. They have real business problems, and they want answers and models in production yesterday. And sometimes they don't even have a data science team, right? So to them, it's just a building block in their app to make their app smarter and create business value, whatever that is. It could be healthcare or education or cost saving or innovation, all of that. So they want to move fast, and they want a fast, inexpensive, efficient solution, and then move on to the next project because they have another 1,000 things to work on. And it's a very different field from research, like the amazing stuff that Meta is doing and other companies is doing is groundbreaking, right? But it needs to trickle down to average, normal customers, and they want the simple models. So it's, we have this analogy with Formula One, like the big science model that we trained with 1,000 researchers. It's a Formula One. It's 176 billion parameters. No one's going to use that. But it's an open model that everybody can use and distill and quantize and prune. And I'm sure we'll see great outcomes out of that. But so that's for the ML community to build the tooling to do that. That's really what people are looking for.
Makes sense. We have 30 seconds, I think. Are there any questions in the audience? Sorry, I have so many questions, but any questions?
One question, how do you collect so many parameters?
Sorry, couldn't hear you.
Okay.
How do you collect so many parameters?
How do you?
Collect
So many parameters.
What do you mean collect?
Like you said trillion parameters. Where do they come from?
Well, you just build, how do you build it's the same as a skyscraper. You build it as high as you want to. My point is, why would you even do that? Do you want to have the tallest building in the world just because? And to me, that's not a really good reason. So having the largest model just because, it's a good PR move, if you ask me. But from a practitioner perspective, it only makes sense if that huge model is used to explore, new research avenues that eventually deliver smaller, actionable models that people can use. Exactly like Formula One technology ends up in your everyday car. But it might take 10 years. Or hopefully won't wait for 10 years, but yeah.
With that,
So yeah, I think his point is, who cares how?
Yeah.
I want to know why.
it's all in the why. Simon Sinek, all in the why. With that, I would really I really want to thank all of you for being part of this panel. Really appreciate it. Productivity versus performance.
Yes.
That's the key message. And think developers. I think that's the key thing. Thank you so much, folks,
Thank you.
for being here with us.